Good evening. This is Mindy Lee from X-Rays. Thank you, Felix and Gaussian Plating community, for inviting me here to give you a topic talks of the SLAM-based 3D Gaussian solution and the applications we've done recently in various industries. So firstly, I want to introduce my team a little bit. X-Rays is not only a 3D scanners producers, as you know, and we focus on 3D intelligent spatial computing and providing integrated software and hardware solutions. And we also want to share the insights about 3D industries. So with the progress of the computing methods from the PC computing one, people use the personal computer to do the content consuming. And then we comes to the mobile computing era. People use cell phone and mobile devices more and more frequently. And when it comes to spatial computing era, there is growing demands of the 3D contents. So, but there is still a large gap between the 3D content demands with the production methods. Because in these days, we have three different ways of modeling. First is manual modeling, which people by taking photos or CAD drawings for model building. But this way, lacks of realistic texture and details makes the model a very fake one. It needs also cost a large amount of labors and money. And when we got photogrammetry, people use photos or drawings for reality capture, which improve the efficiency a lot. However, it also performed bad in some very complex cases, especially indoor, and the case has some windows and reflective surfaces. It may generate the result with broken surfaces, shadows, and blur parts. And we also got panoramic image and videos by 360 cameras. It meets some requirements of the 3D navigation and roaming. However, it's not a real model, and it also has some distortion in the margin, and it's also restricted the immersive experience. So that's why X-Rays want to provide a much more innovative 3D content production experience. From this point, we produce 3D mobile scanners, and by taking the mobile scanners, you can do the reality capture in a mobile and efficient way. And we generate different kinds of deliverables for specific purposes. Firstly, we generate color point clouds in real time, which means that by using our mobile scanning system, you can get color point clouds right after you finish the scan. And we also generate mesh models for indoor cases. And then when we adopted 3D Gaussian splitting from last year, we got the 3D we got a Gaussian split solutions called LCC. Today, I want to introduce it to you in a more detailed way. Firstly, we use our lactoserial scanners for reality capturing, and our generation is based on local methods. So that's why we can generate the Gaussian split in a very efficient and high quality way. So what makes our solutions different from others is our multi-SLAM algorithm. And to make it in a clear way, multi-SLAM, which means we combine different sensors into the SLAM system. And SLAM means simultaneous localization and mapping, which is mainly used for mobile scanning system. So most of the Gaussian splitting solutions only use the camera or the visual sensors for reality capture. However, we combine the LiDAR with the visual sensor to make the mobile scanning much more robust, and we got a better result in a very complex scenarios, especially in some corridors or very feature-sparse sites. And our innovative 3D Gaussian algorithm also make it very efficient because you don't need to take take a large amounts of photos in different directions or on different heights. You can just take the scanner and walk around, and so that you can get the Gaussian splays from outdoor to indoor, and from different levels or stories of a building. So that's the features of our solutions. Firstly, you can use the mobile scanning system to scan a very large scale and complex scenes. It can also perform good in a low light and feature scarce sites. And just because we come from the surveying industries, the scanners also reach a centimeter level accuracy, and you can do the measurements in a very efficient way. Other than that, you can put the deliverables into various multi-terminals like cell phones, iPad, and the VR headset and AR glasses. So let me put it further. So firstly, we use mobile scanners like this. It's a very compact scanners. You don't need to take different kinds of equipment with you. You only take one so that you can just walk around in the site, and you can scan a very large scale scene. And this one, in this case, it's also a very complex museum with a dark light, and you can walk around the dinosaur skeleton and keep the whole structure within your scanner and generate a very good quality result. And here we also can do centimeter level accuracy measurements based on the 3D Gaussian splays. And for a more immersive and interactive purpose, you can add some annotation and notes based on our results. It supports text, image, video, and hyperlink, which means that you can not only roaming or navigate in the models, you can also share the information with different kinds of viewers. And then people can also add some additional information about the specific points, which make it much more applicable for some virtual tour purposes. Here, we also have some AI-powered features for making better models. For making a better model, this one is a case we scanned in a very crowded and famous tourist attraction in Japan. When we scan, it's really crowded in this case, and we just walk around, and in the data processing software, we just rip out all the dynamic objects and the people here to make the model much more cleaner and applicable. And other than that, we also have some clipping features for a more usable result. By clip the models on half, you can see the structure and floor plan in a very clear way, and you can also rip out the models or parts that you don't need to make the models or results much more clean. And as for large scale scanning, we can not only scan one site, you can also combine different space scanning results into one. And so that to make your viewer can jump from one scan to another. As a whole, it can be much more interactive for the viewer and the users. Actually, we know that we cannot do all the applications by ourselves because the 3D content needs comes from various industries. So other than the application viewer developed by ourselves, we also bring about the developer platform for development toolkits like WebGL and Unity and Unreal Engine's SDK. By all these kind of toolkits, you can input our results into different viewers on various devices. And you can also develop the features like clipping box and annotations by yourself. And you can also do the 3D asset input and overlay for further application. And collision and reality is also usable in Unity and Unreal engines for different kinds of application. Here is a very brief workflow Firstly, we use like serial scanners for reality capturing. As I said, you can take it. It's a handheld scanner, so you can take it and work around for the scanning, whole scanning things, and then you input the data into the laptop and do the automatic processing based on the local software. And when you get the deliverables, first you can use the local viewer LCC viewer to do a local viewing, and you can also publish it on the website and to make a web link that you can share with your customers and users in a very efficient way. And finally, you can also export the models and import it into the Unreal Engine or Unity engine for further research and developments. Here is efficiency comparison. Take this 25,000 meter square park as an example. In the traditional way, people may do the reality capture thing for 1 to 3 days, and it will take 10 or more days for an office work by using the software like the 3D Max and the Blenders to do the modeling. But by our LCC solutions, you can just use the scanner for 20 minutes scanning. You can complete a whole park scanning, and then the processing may take 300 minutes, and then you can just publish the results onto the website for within 1 minute. All the things can be done within half a day, which makes the workflow and efficiency very, very easy. So does the efficiency really matters? My reason is absolutely yes, because when you can generate 3D contents more and more quickly and frequently, the ecosystem will be more vibrant, and more applications and imagination of the 3D can be stimulated. So in the following parts, I want to introduce several cases and applications we've done recently with our partners and by ourselves. Firstly, is about the virtual tour, because other than viewing the models, people can also do an online gallery and exhibition in a very easy way. So on the left hand is an online gallery I scanned in Chicago, and people can not only see the whole site, and they also can read some additional information about artworks. And on the right hand is a case done by our partners in China, which this one is cannot imaginable in the past, because modeling is a really labor cost thing. But in this time, we can use the scanner only 1 day before the exhibition, and they can just scan and generate models within half a day, so that they can make the exhibition online right after the exhibition starts. And in this case, we also use 3D Gaussian splitting for cultural preservation, and the scanning and the generation happens with cultural relics. And this Sphinx is scanned by our United States partners. And this one, we also put it into the Apple Vision Pro for an immersive experience. So these days, people can not only see the cultural relics with the photos or videos, they can also, with an avatar, they can get into the site and have a very immersive experience. And here is another case developed by our Japanese partners, Active Retech, and they scan the Osaka temples and put the results into mobile phone application. And this one using the Lexo L2 for scanning and LCC Studio for the model training. And the Unity SDK is especially for their application developments. And other than mobile phones, people can also use the results for an iPad experience. And with the joystick, you can also get a much more funny navigating experience. And other than the entertainment purposes, the 3D Gaussian displays can also be used in a very industrial cases like the AEC industries. This scan to bin case is done by K1, the compact scanners with the LCC Studio for training. And this one is done by our US partners. They use the scanning system for an office scanning. And in this case, their colleagues and the designers based in different states. So they use the results to do viewer and ideas sharing. They can also do the measurements based on the office. They can also put the result into the Rabbit for beam model building. So they can use it as a real-time reference, which can transmit the information efficiently. And this case is an engineering management case. On the left hand is 3D Gaussian result by LCC solution, which can be used in on-site inspection. And on the right hand is an overlap of the beam model with the site models, by which people can compare the design model with the real site to see whether there is a difference between the beam with the real site. And they can also decide whether there is a place need to be modified. And here is another case of real estate. So people can post the 3D models online for the online business and designing for decision making. And you can not only viewing the models, you can also use the clipping box to see the structure of the house and make the floor plan design more efficiently and accurately. So that people don't need to cut joints. Maybe people don't need cut joints anymore. People can use it as a more visualized way, more efficient way. And we also put it into, and we also use the LCC solutions and came into the filming industries by virtual production file. In this case, our customers use LED screen to project the 3D Gaussian splitting result. And before the screen, in front of the screen, people just use that solutions for virtual production and shooting. And real people and avatars can be in one site, and they have a very good 3D relationship, so that they have correct 3D relationship to make the whole site much more realistic. That's the way people in filming industry using the 3D models for virtual production. And by all this kind of 3D applications and cases, X-Grades want to push the 3D Gaussian splitting technology further. So we think that it's really a photorealistic and amazing technology for viewing, but we do not want to stop by visualization. We want to adopt the technology into specific scenarios in industries. And we just welcome all kinds of professional developers all around the world to build these ecosystems into a better one. And thank you, or I think that's word of my topics, and thank you for listening.